CNT125, Chapter 8, we're going to look at the section on how subnet masks work. A device uses a subnet mask to determine which subnet or network it belongs to, and eventually what network it's going to. An IP address is divided into two parts. We should remember the network portion and the host portion. And we should hopefully remember with Class A, the first octet is network, the remaining three are host. That's the default. With Class B, the first two are network, the remaining two are host. And with Class C, the first three are network, the remaining is host. That's our defaults. When a PC is ready to send data, it's going to compare its bits in its own network ID with the network ID of the destination. Where is it going? And it'll see, okay, if they're on the same network, it knows to send it right to that node. So if my network and your network are the same, network ID are the same, it knows to send it directly to that node. If the network ID is different, from that it goes, okay, you must be now on a different network, it's going to send this to the default gateway, which is usually the router you're attached to. And the router would then be able to look up, oh, okay, you need to go over here to this network, and it will route it to that network. That's the job of the default gateway, send the data to the correct destination. And that default gateway is usually a router that your device is attached to, and it'll route it to the correct destination. So the subnet mask is now, it's used to know what part is network, what part is host. The ones in our subnet mask are there to denote the network and the subnet portion. The ones in the subnet mask are used to represent the network and the subnet portion. So if I look down here at the subnet mask, here's the subnet mask down here. If I look at that in binary, over here's the binary. All of those are the network and subnet portion. The 255, 255, 255, these are all network and or subnet pieces. Okay, so those are the network bits. That's what that's telling me. The host portion is represented with zeros. So over here, again, the last octet was 0. So the last octet over here in binary is all zeros. So this right here, this subnet mask written out in binary shows you network, 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 and the remaining octet being host, all zeros. That's what it's actually showing you. So hopefully, again, you remember from 120 and earlier this chapter, the default subnet mask for Class A is network host 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 255.0.0.0. We should also hopefully remember Class B is network network host host, so 255.255.0.0. And Class C, we should hopefully remember 255.255.255.0. So network 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 host. And over here are the decimal equivalents of those. Okay, hopefully we should remember that. Those are all the normals. We need to remember the normals to know if subnetting has occurred. Well, let's take a look at this. If I have an IP address, 95.15.32.12, 95 tells us this is Class A. Remember your first octet rule, Class A. So we should be expecting network host host host. We should be expecting 255.0.0.0. The network ID is 95.0.0.0, host portion all zeros. That identifies the network. So network ID 95.0.0.0. If the subnet mask is 255.224, we know we're like, smells funny. Yeah, this is the subnet piece. Subnetting has now occurred because it should be 255.0.0.0, but it's now 255.224.0.0. That's letting us know subnetting has occurred. So we need to remember these normals to know what is different. If I look at a address now, 135.15.32.12, 135 tells us Class B, so we should be expecting network network host host for our octets. We should be expecting 255.255.0.0. We know the network ID is 135.15.0.0. We set the network portion, we leave the network portion alone, set the host portion to zeros. That identifies the network. If the subnet mask is 255.255.240.0, this is the piece that's changed. That is now our subnet piece. Subnetting has occurred. If I look at another example, 195.15.32.12, 195 tells us class C, we should be expecting the first 3 octets network, the last one host. We should be expecting 255.255.255.0. My network ID is 195.15.32.0. We set the host portion to 0. That identifies the network now. If our subnet mask is 255.255.255.192, we know this is now a subnet piece. We know subnetting has occurred. Those are the pieces we should remember about our subnet masks, and or the pieces we should start fitting together about our subnet masks. The subnet masks are telling us what part is network, what part is subnet if there is any. In this case, I'll back up here one. This would be the subnet piece, and what part is host. What part is host. That's what we should be remembering about our subnet masks.